All right, so let's build a Java data model that it can interact with a relational database. Let's see. Let's keep using this same example that we've been using throughout the semester. If we go to our relational database, here we have a couple of tables for our course here. We have a student table and we have a course table. They could be also a section table, an enrollment table, a department table. So here we have the courses table, and let's see what we have here. Oops. Let's see if we have any courses. We do, right? So we've selected all the courses, and we have, let's see, we have CS 5200, CS 5610, CS 4500. Plus, we would have all other sort of things in here, right? But let's keep it simple. It's just it has a unique identifier. And I believe that identifier is an auto increment. We can see the structure here. We can send the create statement that was used to build this. There it is. It's just the table is a courses table. It has an ID. It's auto incremented. We have a title, which is a varchar, 45 characters, and the primary key is ID. All right. So somebody has decided to create this relational database model. We want to create a Java equivalent to this. All right. All right. So let's head over to Java, and we would want to implement here in the models package, right? We're going to create a courses that represents that model, right? So let's do that. Let's create a new Java class. So this will be courses, and we would have the same fields that we have in the table. So we have here perhaps a private integer ID. And we have private string title. Right, and let's add here the setters and getters that go along with this. Okay, all the setters and getters. Plus, we'll add a couple constructors. But in Java, you get the default constructor for free. Right, the default constructor is the one that takes no arguments. Right, so I wouldn't have to declare here. But it's very common that we want to have an all argument constructor alongside with that, right? That overloads the no argument constructor, so that we can provide the ID, we can provide the title, right? So that we can instantiate these objects, right? So let's create a constructor using all the fields. We'll say right after the title. Very good. There it is. It takes this.id and this.title to instantiate it. Plus, but now because we've overloaded it, now Java does not declare the no argument constructor for free anymore, right? We need to explicitly declare it. So let's explicitly declare the no argument constructor. So let's do that. Source generate a constructor with no fields. And after the title, there it is. Okay, that's the no argument constructor. All right, so we have courses, and we would like to be able to now somehow map, right, the data model in the relational database with this data model here in Java. Okay, excellent. So let's see. We need to be able to. We're gonna encapsulate all data access to a database, right, into a data access object, right? That's a very common design pattern. A design pattern is just courses, DL. A design pattern is a best practice that has been identified in a particular industry that has worked very well. And that folks tend to reuse them where they work, right? And there's also anti-patterns, things that you should not do. So good design patterns are things that you should do, and anti-patterns are things you shouldn't do, right? That the community has identified through multiple, having worked many years on a particular set of problems. So a DAO is a very common design pattern where we want to we want to modularize all data access into a dedicated set of classes that deal with this, right? So that they can provide a nice API to the rest of the application. So the rest of the application doesn't have to deal with data access and getting the connections and none of that, right? It basically creates the model, right? It creates how the rest of the application thinks about the data, right? They think about it using these finders, these creates, these updates, these deletes. That's how the rest of the application understands how the data behaves through this data model. Okay. All right. So another good design pattern typically is that there should be only one instance of these data access objects at any one time. Right? There should be only one instance of these things hanging around. That's another design pattern. It's called the singleton design pattern. Right? That there should be only one of these at any time. So to do that, we can implement a the singleton in many different ways. But one particular way is to first make the constructor unavailable. Right? So folks will not be able to instantiate these objects at any time they want. Instead, they'll have to go through a particular API that we can control. Right? So folks are not going to be able to say new course DAO, right? Outside of this class. So it's only private. Okay? Course says DAO, sorry. Right, so we're disallowing anyone outside of the class to be able to say new courses DAO, right? Otherwise, everybody would have their own particular instance, and that's what we want to stop folks from doing. Instead, we're going to have a private, static, a single instance, one single instance throughout the lifespan of the application of a courses DAO, and it's going to be the single instance, which we're going to initialize to be null. Okay? So somebody needs to instantiate that. Somebody needs to create it. And so what we'll do is that we're going to make a public static function that allows us to retrieve the instance, your get instance. Right, this is the only place where we can possibly get an instance of this object or of this class. Right? So what we're going to say is that if the instance doesn't already exist, right? So if it doesn't already exist, I'll instantiate it. You know, just this once. Right? We'll say that instance is new courses DAO. But if it already exists, I'm just going to return to you the instance that already exists. Okay. So this is the single place where the how we could possibly get a hold of this course DAO. Make sense? Right. All right. Excellent. So we have that. What else do we need here? Well, we'll probably need a place where we can get actually access to a database. We'll probably need the connection string. It probably will be private. Will be probably final. So it'll be a constant. So this will be a connection string. And this will be something like JDBC, colon, MySQL, colon / is it? Localhost 3306, and then the database, I think, what do we call it? CS5200 fall 2018. So CS5200 underscore fall 2018. Typically, this would be provided as a separate configuration file, or maybe even an environment variable as part of the server that can be read from your application. Let's keep it simple here. We also probably might need a username, and I believe I had already created a CS5200 user. And and a password. I believe I created a username that has username and password to be the same. What else do we need? We'll probably need a connection object that we're going to initialize to be null. And if I hover over this, notice that it gives me as option the interface, java.sql connection, That's the one we want to compile against, right? We don't want to compile against the com.mysql.jdbc. That's the implementation class. That class is implementing this interface, right? We don't want to compile against the vendor implementation. We want to compile against the interface, so that if we want to change the vendor, our code still works. Okay? So we're gonna compile against the interface. We'll also need here. We'll need the statement. We'll need the result set. Okay, and all these are the Java SQL version. Java SQL version, not the MySQL version. All right, so what else would we have here in the DAO? As I mentioned earlier, it's the responsibility of DAO to provide an API to the rest of the application to interact with the database, right? So things in here that would live here are things such as create a course, right? And we would provide an instance of that course that we want to create, right? What else do we want here? Let's course is did we create course? Oh, courses. Oh, I don't like the name. Courses. Ew. It's one single instance, right? Oh, the table is called courses, right? Actually, no. Let's rename that. Let's rename that. Let's see. Let's import it, and then I believe we can just name it here. We can refactor, and doesn't allow me to rename it. Really? Rename. There we go. So I'll change it to course. Yes, change everywhere. Let's see if it changed. It did. All right, it changed. So the table also should be singular, right? I don't particularly like plurals, just because it's not consistent the way you pluralize things, particularly in English. So I prefer to just keep everything singular, so there's no misunderstanding. So as long as we all agree on the naming convention. All right, so we have create course. What else do we need here? Probably we'll have a public find all courses, right? And probably that's going to return a list of courses, right? For now, we're just going to return null, where the list is a collection. So Java utils, there we go, excellent. What else probably lives here? Probably we want to identify and retrieve a particular course. Find course by ID. Where we provide the ID of the course, and this would return that particular course. What else would live here? We'll probably also want an update course. We would provide the ID, and we would provide the new course information that we want to update. Right now, we're going to return -1. Probably that would return how many records were updated. Yes? Yeah, that typically you would have a separate singleton that would deal with the connections and would deal with all that. And we give you that as an example in the assignment. So those 6 lines would live. These 6 lines would be in a separate singleton. Yep, that would be shared amongst all DAOs. Right. Right. What else would live here? We would have maybe delete course, where we have maybe the ID of the course that we want to remove. Will live here. So anything else that would go here, like for instance, if we have a section for that course, would probably live here as well. Things like that, or the department that this course is being taught for, right, would live also here, right? Any relationships with a one-to-many or many-to-many would live us here here. All right. All right. So let's do a couple of these. Let's do a find all. All right, so let's do that. So to find all, let's see, we need to get a hold of the connection. So connection, we would need to, well, first of all, we need to load the driver, right? So we're going to do something like class.forName, and I believe the class is something like com.mysql.jdbc driver, I think. right? And we're going to have to surround it with a try catch. We're also going to need to. So now we have the driver manager. It's been instantiated. So now from the driver manager, we can get a hold of the connection, get connection. And the connection can take as argument the connection string. It can also take, optionally, it can take the username and take the password. The password, there it is. Right, and I think this throws an exception, so I'm going to surround it, add a clause. There we go. All right, so now we assign it to the connection. Now that we have the connection, we can now execute the query, right? Select star. So the query might be something that also lives here. So it could be something like a private final string find all courses. It'll be something like select star from courses. Okay. And then so here we can do grab a hold of the statements. So statement is connection dot create statement. And now we can execute that query. We can say statement dot execute query, and the query is find all courses. Right? We've executed the query, went out to the database, retrieved all the rows, and we're going to assign them to the results here. Right? We have the results there. We can iterate over those results, put it inside of a while. So results next. And as we iterate and move the cursor down, right, we're looking at each row at a time, and we can retrieve all the fields one at a time. So we can retrieve the ID. We don't really, we'll retrieve the ID. So we'll get results.getInt, and so we can give it the name of the field. We can get a hold of the title. So results.getString, and then title. And then we can instantiate the course. So it'll be course, new course. I can't type. And the constructor can take two arguments. So we can pass in the ID and we can pass in the title. Right. So that now we have the course. We can create maybe a list of these things. We can say list courses as an array list of courses. I already have our array list. List courses. What are you complaining? New. Sorry. New. So let's import that. And we can add each one of these courses to the courses. So courses.add course. And finally, the last thing here, we can return the courses. All right, so let's try it out. Let's see, int, no? Int, okay. We can run it just to test it. You can either have a unit test, or from right here, we'll create a little main. Yes? I got it wrong? Thank you, 3306. All right, so let's create a little main here that we can test. So public static void main that has string arguments, and we can get a hold of the DAO. We can say the course DAO is course DAO. Course DAO. Dot hello. Why aren't you seeing it? What?
Courses DAO.
Did I call it courses DAO? Yeah. Sorry. Refactor, rename. Course DAO. What? Okay, whatever. Course says DAO. Dot get instance. There we go. So now we have the instance, and we can retrieve the list of courses. So, oops. So this is courses, DAO.find all courses. And then we can just iterate over this, right? So for course, and courses, we can print this. We're going to do system.out.println and print out course.getTitle. All right. All right, so let's try this out. It's still complaining about something. What is it? What don't you like? Project. Build this. All right, I think we can run it from here and say run as a Java application. Yes, maybe, no? No? What, let me see. Am I even here? Oh, save and launch. Cancel. I think I was too eager. Course, yeah, run it here. Are you building? Are you doing something? No suitable driver. J, is that misspelled? Oh, am I missing a colon somewhere in there? Colon // right? Yeah, it's colon //. Try it again. There we go. So return all the three courses. One point that I'd like to make is that say you want to retrieve a particular one, and so for instance you want to implement find course by ID, right? You would be tempted to do something like this: select star from courses where ID is equal, and then maybe then concatenate the ID to this, right? But that opens you up for SQL injection, right? Because that string that you are appending, right? That might come from a form that somebody filled out, right? And that form that users could fill out are potentially risky. That folks could post anything they want in there, right? Even malicious SQL that could thwart your query. So instead of let's do the same thing, and let's re-implement this, but implementing find courses by ID. So I'm just going to copy this. I'm just going to paste it in here. So a find courses by ID, you would do something like this, right? Perhaps. Let's see. Find course by ID. It's just one course. It's just one course. So just have one course. Right, and it initially is null. You get the connection, blah, blah, blah. You get the statement. Here the string would be something find course by ID concatenated, right, with the ID that you pass as an argument. Yes? And that builds a string, and then you can execute the query, right? But again, that concatenation is dangerous. Right, because we're not validating the string. There could be anything in there. We were expecting maybe a date. Instead, it's not a date. We're expecting a number, but it's not really a number, right? So we're not doing any validation. So instead of using a statement, right, more commonly what we do is we use a prepared statement. Private prepared statement. Statement. There we go, that one. P statement. So a prepared statement is a more powerful version of a statement, right? In that you can compile them, right, at runtime, Okay, and then you can reuse them over and over without having to concatenate anything, right? And it can do validation for you, right? So that if you're expecting an integer, it'll be an integer, right? That if you're expecting a date, it'll do strong typing, make sure that it validates all these data types for you. And if it's a string, it makes sure that there are no malicious characters in your strings, right? It escapes everything correctly, and it validates all of the stuff. So instead of using a plain old statement, what we could use, we still have to, put the value in there, right? The ID somehow. So prepared statement, what it allows you to do is provide placeholders, right? You can provide a placeholder that you can then use the prepared statement to, feed in what those values should be without using concatenation or anything like that. All right, so let's do that. All right, so let's go back to the find by ID. So there it is. So find by ID. So yeah, so we don't want to do this. We don't want to do that. This concatenation. So what do? So what we're going to do is instead we're going to use the P statement. Right? So we're going to use the P statement instead of create statement. We're going to use prepare statement. Prepare statement as opposed to create statement. Make sense? And what we're going to provide here is the find course by ID. There it is. Find course by ID. Meaning compile this, compile the statement, and then I can parameterize you. I can give you the parameters that you're missing. In this particular case, it's the ID. All right? So let's do that. We're going to do P statement. I'm going to set the integer for that parameter index, right? The question mark that is missing, right? Those are indexed. You can have any number of parameters. For instance, you can have, update a course, set the title, right, where the ID of the course is whatever. You can have any number of placeholders, yes? And you can refer to them by index. The first question mark in there is position number 1. Right? They're based on 1, not base 0. They're base 1. Right? I don't know why. Java, everything's base 0 except SQL. And then the value that I want for it is ID. Okay? Now this is going to know, I know I need an integer here. Right? I know it's an integer. So it's going to validate that the ID is really an integer. It doesn't have any malicious strings or anything in there. Right? So it uses strong typing. Once that we have that, we can then execute this statement. We can execute the statement. We can say P statement dot execute query. Right? We can execute the query. These are also very useful because you can compile it once and then reuse them over and over and over, just changing the parameter. Right? So they're much faster too, especially if you're using them in the loop, right, where you're iterating over an outer query, and then inside you're iterating over an inner query. Right? The inner query could be a prepared statement and just change the properties, the fields as you iterate over the loop. All right, so there we go. Okay, so presumably this is a single course. Only one course exists with this particular ID. Yes? Right? So it makes no sense to iterate over this because we know it's just one. Right? So instead of a while loop, what we'll do is do an if. If there's a row, right? If there are any courses that match this ID, then I want that course. I want that course. So we're going to read the ID. Hopefully it's the same ID that we gave it as an argument. And we retrieve the title. We instantiate the course. And then we are ready to return the course here. And we return the course. There we go. All right, so let's try it out. And so we're printing out all the courses. And then we're just going to retrieve that one course. So course DAO.find course by ID. Let's see, let's retrieve 4500. That's number 3, ID number 3, so 3. Right, so we're going to say course dot, so we're going to say system.out.println course.get title. Okay? All right, so let's try it out. Let's run it, see if this blows up. There it is, right? So we printed out all of them and then that one single course that we retrieve. Make sense? Right? Right, so this is the beginnings of writing a DAO. Obviously, you would implement all the other ones, the inserts, all the updates, or the deletes, right? Similarly, right, you would create you would create strings for each one of the each one of the use cases, right? That would insert, that would update, and then you would use prepared statements to feed in all the question marks, all the placeholders. Make sense? All right, thank you.